Okay, guys, sorry about that. We had some technical difficulties on that last round. So this is where we left off on the work rate problems, the last kind of problems in that section. See, I got my arrow back, which I just needed to be able to tell what I'm selecting over here. If you're wondering, why didn't I just finish? I need that arrow to see what I'm doing. Okay, work rate problems. Work rate problems are problems that involve two or more things working together on one job. For example, this one's about two people painting a house. This one's about two pipes running in a pool. It could be two copy machines copying papers, right? Two or more machines or people working together. The key is to figure out the individual rate of each person or machine. So if Joe can paint a house in 3 hours, his rate per hour is 1/3. He does 1/3 of the house every hour. If Sam can paint it in 5 hours, he does 1/5 of the house every hour. Meaning after 1 hour, he's got 1/5 of the house painted. After 2 hours, 2/5 painted. After 4 hours, 4/5 painted. After 5 hours, 5/5, or one whole house painted. Right? So this pipe is filling 1/5 of the pool every hour if it can fill the whole pool in 5 hours. All right, so I do each individual speed. So Joe is going 1/3 of the house per hour times the time. You can use a T here if you want for time, but it's 1/3 times the number of hours. So our X or our T is the number of hours they're working. And then he's working together with Sam, so I'm just going to add Sam's painting rate to it. And it's always going to equal 1. 1 in this case, when is one house going to be painted? When is one job going to be completed? And there's our equation. These are all basically the same. They're based on these two ideas. We may have, as we'll see down here, a little bit of difference, but that should be obvious, hopefully. Now just solve this equation, which involves getting rid of the fractions. So I need a common denominator, which is 15. Multiply all the way across with our 15. 15 divided by 3 is 5. So 5x plus 15 divided by 5 is 3, plus 3x equals 1 times 15 is 15. So 8x equals 15. X equals 15/8. And now, because this is an application problem, we're not going to say, oh, we can paint that house in 15/8 hours. So I do, in this instance, want to turn that into a mixed number. However, they are not going to be more specific than that. We can say, which we really wouldn't in real life, but here we can say, oh, I'm going to do it in 1 7/8 hours. It will take them 1 7/8 hours. I'm not going to have to convert that down to minutes. Okay, same kind of problem, because I see, oh, I've got these two pipes, right, working to fill, or in one case, empty a pool. So an inlet pipe can fill Blake's pool in 5 hours, meaning it's filling 1/5 of the pool per hour, while an outlet pipe can empty it in 8 hours. So it's emptying 1/8 of the pool every hour. In his haste to surf the internet, Blake left both pipes open. How long did it take to fill the pool? All right, same kind of problem, two pipes working on this pool. So the first one is 1/5 of the pool is filled for every hour it's left running. 1/5 times the number of hours. The other one is emptying 1/8 of the pool for every hour it's left running. What do you think is the difference between this problem and this problem? You're right, I hope. This time we're going to subtract. If it was saying these two pools were running into the, if it were saying these two pipes, were running into the pool to fill it, then I would add them. But this one's emptying the pool. So I'm going to take that away, but it's still going to equal 1 because I want to know when one pool is full. All right, common denominator is, so multiplying everything by 40, we have 40 divided by 5 is 8, so there's 8x. 40 divided by 8 is 5, so there's 5x. And 1 times 40 is 40. So 8x minus 5x is 3x equals 40 divided by 3. So x is, instead of 40 thirds, what's that, 13 and 1/3? So we can say 13 and 1/3 hours it's going to take to fill this pool. 13 hours and 20 minutes would be a better answer, but they're going to let us leave these, I believe. Okay, also think about this. If these guys are working together, then I can expect I better get a number less than 3 hours. Joe can do it by himself in 3 hours, right? So if he's got some help, it should be less than 3 hours. Same thing here. This pipe can empty the pool in 8 hours, but as long as some's running in, then this should take longer than 8 hours to empty. So I also might kind of use that as a check or a guideline for us to help us determine the reasonableness of our answers. Okay, that finishes 1.6.